A mission NASA hopes will tell us more about the origins of our solar system and maybe even life itself got one step closer to liftoff. Here is what you need to know. NASA plans to launch the first spacecraft ever to study Jupiter's Trojan clusters, a group of asteroids that share Jupiter's orbit around the Sun. NASA engineers recently got the green light to assemble and test the spacecraft, the space agency announced in a press release on August 28th. Lucy, named after the world's most famous human ancestor skeleton, will first visit 52246 Donald Johanson, an asteroid in the main asteroid belt between Mars and Jupiter. The asteroid is named after the discoverer of the Lucy fossil. Lucy will then head to its main destination, 6 asteroids in Jupiter's Trojan clusters. Because these asteroids are believed to be the remnants of what formed the planets, scientists hope they will yield clues about the formation of our solar system. Jupiter's Trojans orbit the Sun in 2 clouds, with one group leading 60 degrees ahead of Jupiter and the other trailing 60 degrees behind the gas giant. The Lucy mission is set to launch in October 2021 and will pass Earth twice for gravity assists. After touring Donald Johanson on April of 2025, Lucy will explore 4 Trojans in the leading swarm in 2027 and 2028. Lucy is then expected to explore the binary pair Patroclus-Manuicius in the cloud of Trojans that trail Jupiter in March of 2033. Jupiter's Trojans only reflect 4 or 5% of the light that hits them, which means dark carbon compounds may exist on their surfaces. Quoted in the press release, NASA's senior scientist Amy Simon said if so, it would indicate that organic compounds, the building blocks of life, were common throughout the early solar system. Jupiter's Trojans migrated to their current orbit 4 billion years ago. The spacecraft Lucy will travel 4 billion miles to reach them. Lucy, an ancestor of modern humans, walked the Earth in what is now Ethiopia 4 million years ago. Her skeleton was discovered by Donald Johanson 34 years ago. It was later named after the Beatles' 1967 hit, Lucy in the Sky with Diamonds. While NASA is interested in the dark spots on the Jovian Trojans, it recently helped make an important discovery about the bright spots on the dwarf planet Ceres. Scientists say they may have cracked the mystery behind the bright spots on Ceres, salty water that seeps out of the dwarf planet. Here is what they discovered. NASA's Dawn spacecraft shot by the dwarf planet Ceres 2 years ago. After conducting data analysis on the Ocator crater, scientists now say Ceres is an ocean world with brine under the surface. These studies were published separately in Nature Astronomy and Geoscience. Ceres lies in the asteroid belt between Mars and Jupiter. Writing in a news release, NASA says the Dawn mission passed the dwarf planet, and from a distance of about 35 kilometers away, the orbiter took crisp images of Ceres' strangely bright areas and made gravity measurements. From the data, Dawn scientists from the California Institute of Technology determined there is a brine reservoir under the crater's surface, about 40 kilometers deep and hundreds of kilometers wide. The brine consists of sodium chloride bounded with water and ammonium chloride, and the salty liquid is apparently rising to the surface. These compounds are organic chemicals, and the brine also reflects light, which explains the crater's bright areas. Exposed brine could be seen in this false-colored image created by the Dawn science team. Researchers say a meteor impact formed the crater millions of years ago and created fissures that reached the reservoir deep in Ceres' structure. This allows the salty liquids to move up to the surface. Like weird space stuff? Well, you're in luck. From water on Mars to methane on Pluto, we've got you covered. According to new research, ancient Mars may have been covered in glaciers as well as running rivers. Here is what they discovered. Scientists say several billion years old valleys on Mars may have been formed by glaciers and not flowing rivers. According to the new study in Nature Geoscience, ancient Mars was both colder and icier than prevailing theory supposes. Why does this matter? Well, the new theory makes it more likely for primitive life to exist on Mars. The team compared the red planet's valleys to Devon Island in the Canadian Arctic archipelago. Writing in a news release, co-author Anna Galofra says the island is one of the best analogs for Mars on Earth. In this image provided by the research team, Mars's Malmi Valley's top is juxtaposed to the channels of Devon Island on the bottom. The scientists' algorithms indicate that ancient glaciers produced channelized meltwater that cut valleys into the surface of Mars about 3.8 billion years ago. This process would explain the similarities between the valleys of Mars and Devon Island. This is not to say the red planet had no rivers, as NASA's Mars orbiter found what looked like big riverbeds. According to researchers, if the glaciers once existed, their ice sheets would have deflected solar radiation. This means ancient life would have had a better chance of surviving on Mars than previously thought. Pluto's cold heart gives warm winds. lovely nitrogen-methane winds. According to a study in the Journal of Geophysical Research Planets, Pluto's frozen heart of nitrogen ice may be the main driver of the dwarf planet's winds. Pluto's heart-shaped Tombaugh Regio is a vast structure made of nitrogen ice, and its left lobe Sputnik Planitia contains 1,000 kilometers of ice sheet within its 5-kilometer basin. Phys.org reports that the study's authors used data from NASA's New Horizons mission in 2015 to construct a weather model for Pluto. During the day, a thin layer of the frozen nitrogen evaporates in relative heat. At night, the gas condenses and returns to icy form. The sequence pumps nitrogen wind through Pluto's atmosphere like rhythmic heartbeats. As nitrogen in Tombaugh Regio vaporizes in the north and freezes into ice in the south, the process triggers a westerly wind. Citing the study's authors, Phys.org says this behavior is unique in the entire solar system, with perhaps the exception of Neptune's moon Triton. The study's other discovery is that Sputnik Planitia's high cliffs trap winds within the basin before releasing the strengthened currents to the west. The atmospheric movement is similar to certain wind patterns on Earth, such as the Kuroshio in Eastern Asia.
For more news animations and explainers, hit the subscribe and bell button to join the TomoNews family. Thanks for watching.